Hi guys, and welcome to this, my video on finding the length of the shorter sides. Part of the right angle triangle, Pythagoras Theorem section of videos. Well, for year 9 in Australia and goodness knows, year 10, year 8 in other countries as well. Hopefully you're going to find this video useful. Before I get started, can you do me a favour? Did I introduce myself? I'm Darren from Maths Guru. So very nice to meet you. Maths Guru, yes, that there, M-A-F-F-S Guru. For you to head over and watch these videos, download the lesson notes, yada, yada, yada. But before I start, can you do me a massive favour and subscribe to my YouTube channel? It's very needy, I know. I have tried crying and there will be background music that's sobbing and wailing at some point. But so very few people watch YouTube videos. If you can actually subscribe, that would be huge. At the end of the day, when I check my subscribers, and I'm obsessed by subscribers, it's very weird. If it goes up by 3, I am so happy, honestly, really, really happy. If it goes up by 5, I'll run around the house like a lunatic. So, yes, anyway, subscribe if you can. What am I going to deal with in this video? Well, that's the stuff you can read if you want to. It's building on the previous video I did, just introducing Pythagoras Theorem, who he was, very good-looking gentleman, funky eye. Yes, and the fact that his stolen, allegedly, equation helps us find the missing side lengths of triangles. Whip! Yes. Now, a recap. Obviously, everybody in the world probably knows the formula of Pythagoras' theorem. C squared equals A squared plus B squared. But in my previous video, I explained how it came about. And ultimately, just to explain again, all we did was Pythagoras found that a number of squares, when put together, created a right angle triangle. And more importantly, he found that the area of this square here added to the area of this square here gave the area of that square there. Now, that's huge, and that's why we've got this side length of C, and the area of this is C squared. The side length of this is A, which means the area of that is A squared. The side length of this is B, which means the area of that is side length. So basically, if I add this area here and that area there, I get this area here, and that's massive. And what Pythagoras, or whoever he got this formula from, said was that C squared equals A squared plus B squared. The area of one side length is equal to the sum of the areas of the other two side lengths. Oh, okay, that's awesome. Let's see what we do. Now, obviously, in the previous video, we sort of looked at finding this side length here, the longest side length, the hypotenuse. But how would we use it to find the shorter lengths? Funny you should ask that. Let's have a look at a question. Let's look at some examples. Right. We've been given here the hypotenuse. And if you remember, the hypotenuse is the one that's opposite the arrow. The right angle I always think of as an arrow. So I'm going to label this now as C. I'm going to label that as A. It's already labeled it, and that as B. All right. I tend not to care what the question labels. I tend to scrub that out and put my own letters in if needs be. All right. So I can go straight to the formula. So we've got C squared equals A squared plus B squared. Right. So do I know the value of C? I do. It's 17. So 17 squared is equal to A squared. I don't know the value of A. So leave it as A squared plus B squared, which is 15 squared. Now, I used to be amazing. I remember all my square numbers, but in this situation, I don't. So I'm going to use my calculator, and I'm going to do 17 squared. He says here, escape squared. Nope. I don't know what happened there. Let's try that one again. 17 squared. Oh, my goodness. Squared gives me 289. 289 equals A squared, still don't know it. 15 squared, I do know, is 225. All right, okay. So how do I get A squared on its own? Well, I've got to get rid of this plus 225 by taking 225 away from both sides. So 289 minus 225 equals A squared. So again, I'm going to do that on my calculator. 289 minus 225 gives me 64. So 64 is equal to A squared. How do I get rid of the square? I square root both sides. So the root of 64 is equal to A. And I know that the square root of 64, so if we do control square root, again, I shouldn't need to do this, is actually 8. So there we go. I got my 8 as my area. Now again, I tend to do this a slightly different way because I like to think of things in terms of areas. So if this was me doing this, I would have basically gone, well, that area there is 17 times 17, which is 289. This area here is basically, what did I say, 225. Obviously, this area here plus that area there must give me this, I don't know, so this area here plus this area here must give me the 289. So I tend to do the 289 minus the 225, and I would have written that as 64, and then I would have just gone straight for the idea of the square root of 64, and I would have said, well, therefore, a is equal to the square root of 64, which is 8. But again, you have to do what your teacher tells you to do, all right? That's going to be the most important part of all of this.